Good afternoon, all. I'm audible.
Yes, ma'am.
Okay. Screen is visible.
Yes, ma'am.
Okay. So let's start. So in last lecture, we have started the uh, revision of the third chapter. Okay. So up to CRC, we were there in last lecture. So today we'll cover the revision of this, and also we are going to see the program related with the CRC, how the CRC is implemented. So the program we are going to do. So before that, I quickly revise you an example of the CRC and what we are actually going to do. So this is the example. So what is given is we have given a frame, then generator, and from the generator and the frame, we need to calculate the CRC. Okay, so for that we are performing the XOR operation. The XOR operation is if the same values are there, then answer is 0. If different values are there, answer is 1. Then the most important thing is we have to add these zeros at the end of the frame. Okay, and the length of the zero is decided from this length of the generator. Okay, so at the last we'll get the value of the CRC. So why I'm telling this is that while doing the program, we are going to implement the CRC in such a way that we'll have a frame, we'll add these zeros, and we'll perform this XOR operation, and we will get remainder as well as the as well as the generator. Okay, so our reminder will be the our final CRC. So that program we are going to do today. So let's start the program. So I'll show you first. I'll tell you how to do this program. So what we are going to do is first we need to take the length of the frame, means how many or what should be the length of the frame that we are going to take from the user. According to the length, enter the frame. Okay, so that will be the next stage. Then again we have to ask user that what should be the length of the generator. Okay, what should be the length of the generator. According to length, enter the generator. After that we need to add these zeros. Okay, and these zeros we are going to decide according to the length of this generator. Okay, so up to this we will do first, then we'll do the next part. Okay, so what I will do, screen दिसते ना सगळ्यांना प्रोग्रामची स्क्रीन? Yes. Okay, so
हाँ
let's,
मैम निश्चय.
okay, what should I do? I should include std.h new.h. Okay, then I'll take main, void main. Okay, then next, what we'll do, we'll include some integer values, integer I. Now we'll require some arrays to store the frame as well as to store the divisor, then to store the quotient and to store the CRC or the remainder. Okay, so to store the frame, I'll take this as a f of suppose 30 to store the frame. Then the length, and then I'll take one more array as n of 30. Then to store the divisor, I'll take div. Then to store the quotient, I'll take q of 30. Then to store the remainder, I'll take q of 30, sorry, z of 30. Okay. Then we'll require the length of frame as well as the length of the divisor. So for length of the frame, I'll take n1, and for length of the divisor, I'll take d1. Okay, and let's take some more values as j and temporary. So up to now, let it be clear. CLR, SCR. Okay, now what we'll do first take the value from the user, that is nothing but the enter length of frame. Okay, so user will enter the length. So I'll store that in percentage %d, comma, and n1. Okay, now take the frame. Printf enter the frame, and the frame value should be 1 and 0. In that format, the value should be 1 and 0. Okay, now for this we need to compare the length. So I'll take for loop here. For I is equals to 0, I is less than n1, comma, I plus plus. Why I have taken? Because your frame should be of length whatever user has entered, that only. So that's why I have taken the for loop here. Now scanf percentage %d, comma, and so we'll store the frame in f of I array. Clear up to this? Any doubt? What we have done, we have just taken the length of the frame over here. Okay, and according to the length we have entered the frame over here. Now similarly take the length of the divisor, enter the length of divisor. Okay, so I'll store it in the d1 scanf percentage %d, comma, and d1. Similarly, take the divisor from the user, printf enter divisor. Okay, again we need a for loop. For I is equals to 0, I is less than d1 value, and I plus plus. Scanf percentage %d, comma, and we'll store it in a div of I. Okay, समजलं इथपर्यंत? So what we have done? What we have done? Only these two steps we have taken. We have taken the frame from the user and we have taken the divisor from the user. Only this much we have done. Okay. Now what we have to do the next part is we have to add zeros. Right? So how we are adding zeros at the end of the frame? So that should be the divisor minus 1. Am I correct? Yes. Zeros कसे ऍड करतो आपण? किती ऍड करतो zeros? These zeros. Hello.
Length of divisor -1.
-1, and that should be added at the end of your frame. Correct? So how we can add it? So where my frame is there, it should start, 0 should be added at the end of the frame, right? So let us see how to add this. So what I will do, I'll write one for loop, tell me whether I'm correct or wrong. So my 0 adding should start from where? Can anybody tell? One second, I'll make this as a n. Okay. Okay, ठीक आहे. तर एंड मध्ये फ्रेम सेव्ह करून घ्या. ओके, सो 0 ऍड करायचा कुठून स्टार्ट झाला पाहिजे? फ्रेमच्या एंड पासून. मला फ्रेमचा एंड कुठे मिळेल? Where my frame ends. So from this n1 value, I'll get the end of the frame. Correct? Suppose मी 8 लिहिलेलं आहे, तर माझा नेक्स्ट 0 कुठून सहज आला पाहिजे? जिथं n1 आहे. Okay, so I is equals to n1. I is equals to n1, then comma I is less than d1 minus 1. Why d1 minus 1? d1 मध्ये काय स्टोअर केलेलं आहे आपण डिवायझरची लेंथ केलेली. ओके, d1 minus 1 and I प्लस प्लस. ठीक आहे, ह्याच्यामध्ये काय होणार आहे मला, तर n of I is equals to 0 होईल. Means after the length of the frame, zeros will be added in your frame by using this for loop. सगळ्यांना समजलं हा फॉर लूप काय केलेलं आहे, कशासाठी घेतलेलं आहे, just to add number of zeros at the end of the frame. And how to get an end of the frame? So my zero should start from where the length of the frame is given. So I is equals to n1, I should less than d1 minus 1. d1 is length of the divisor, so that should be minus 1 I and I plus plus, and the zeros will get added. Now what the next part we have to do? So we have taken this frame, then we have taken this divisor, also we have added these zeros also. Now next what we are going to do, we have to just check every value, each and every value of this frame, and we have to perform the exclusive OR operation. Okay, so now what I'll do, I'll write some code over here, please pay attention. So what I'll do, for for I is equals to 0, then I is less than n1 I plus plus. Okay, pay attention what I'm doing and tell me what is there. Okay, काय करते ते तुम्ही सांगा मला. I hope you will understood this. If n of I is equals to 1, then for j is equals to 0, j is less than d1 j plus plus. If n of temp is equals to j, so the n of temp is equals to 0 and f of j is equals to 0. Else n of temp is equals to 1, equals to 0. So 1. Okay, temp is equals to 10 plus 1 and q of I is equals to 1. Okay, now tell me what I have done. Does anybody tell? Hmm? What is given, what I have taken, what logic we need to apply over here is that, see here, what is the condition if n of I is equals to 1? What is there in n? It is our frame. Okay, so if n of I is equals to 1, then come down. Okay, q of I is equals to 1. Okay, so what is the condition if n of I is equals to 1, then q of I is equals to 1. So this is applied for this one. Okay, means what, frame मध्ये जर फर्स्ट व्हॅल्यू 1 असेल तर कोशंट काय येतो माझा 1 येतो. Correct, so that is what I have written over here. If n of I is equals to 1, then q of I is equals to 1. Else 1 नाही म्हणजे काय असणार आहे 0 असेल. So if q of I is equals to 0, then what is the sorry n of I is equals to 0 असेल तर quotient काय येईल 0 नाही. ठीक आहे. So that is what we are checking at the first. 1 असेल तर इथं 1 घेतो, 0 असेल तर 0 घेतो. So that part is done. Then next पुन्हा काय केलेलं आहे. Next what we have to do, we have to apply an XOR operation. ठीक आहे. So XOR operation as I told you same values असतील तर 0 otherwise 1. So that is I have written over here. If temp variable हे घेतलेलं आहे, if n of temp is equals to divisor of z. Okay, means जर सेम असतील व्हॅल्यू दोन्ही पण 1 1 0 0 whatever, then value or answer should be 0 as well as its remainder is also 0. So this is done. So 0 0 असेल 0 0, 1 1 असेल तर 0, and if this condition fails means else, otherwise the answer is what 1. ठीक है. So this condition is for XOR operation. Please pay attention. Okay, and up to what it will execute. So up to the end. For I is equals to 0, I is less than n1 and I plus plus. So up to the end of your frame, this same program will execute. Okay, so this is done over here. So only this much, and again we have to continue with the same loop. Then once we up to this same procedure we are going to follow. So we have now the remaining part is only display the values over here. Printf. So I'll display first quotient. I'll write short form quotient is percentage d comma. So quotient we have stored 1 second, we need a for loop over here. Quotient is for I is equals to 0, I is less than n1 I plus plus percentage d comma q of I. Okay, quotient is there, and finally we'll get the remainder. Printf remainder is for j is equals to 0, j is less than n1. No, remainder should be d1 and j plus plus. Remainder should be the d1. Okay, d1 is the length of the divisor. So तेवढाच lengthच आपल्याला रिमाइंडर लागेल. Okay, printf percentage d comma remainder is f of j. Okay, finish it. This for loop is over, this is over. Again everything this is over. Okay, and only we need a get switch over here. Get switch. Okay. Okay. Let's see whether it gives. दिसते ना स्क्रीन? Enlarge केलेली स्क्रीन दिसते का? Yes, screen is visible.
Yes. Yes, ma'am.
मॅम 18 आणि 19 लाईनला सेमीकोलन राहिलाय.
काय राहिलंय सेमीकोलन?
19th line.
Okay. Semicolon. ठीक है. So let's see whether it gives a proper output or not. Okay, let's compile. Okay, run. Okay, so length of the frame is what? Mm, the length of the frame is 10, I guess. Okay, now enter the frame. So I'll enter 1 1. Afterwards, you just check it whether it is giving proper output or not. Okay, so 10 values are getting entered. Then enter the length of the divisor, for example 5. So divisor is my suppose 0. So quotient is given, reminder is given. So I had checked this program, so it is giving the correct answer. Still you just check it. Okay, so just need to show or some modification I want from your side at the reminder, because this reminder it is giving at 4 5 values, so it just should match to the length of the divisor. Okay, that is required over here. I hope the program you get understood. Is there any doubt what we have done? Hmm? It is very easy. Only we need to go step by step. So काय काय केलेलं आहे चेक करा. फर्स्ट काय घेतलेलं आहे आपण लेंथ ऑफ द फ्रेम युजर कडून घेतलेली. ठीक आहे. सो जेवढी फ्रेमची लेंथ असेल तेवढ्या व्हॅल्यूज एंटर करून घेतल्या 1 आणि 0 फॉर्मॅट मध्ये. आफ्टर दॅट what we have taken length of the divisor and according to the length divisor enter करून घेतला up to this. After that we have to add number of zeros. Okay, and 0 should be less than divisor, so that's why we have taken this condition for loop. Accordingly फ्रेमच्या एंडला zeros add झाले. How end? Because the loop is starting from n1 itself, and n1 is nothing but my length of the frame. So if suppose I have given the 10, then next value will be 0 up to the length minus 1 of divisor. So zeros are getting added over here. ठीक आहे. आफ्टर दॅट आता झिरोज ऍड झाले, फ्रेम घेतली, डिवायझर घेतला. ओनली थिंग इज रिमेनिंग इज व्हॉट? एक्सऑर ऑपरेशन. सो एक्सऑर ऑपरेशन फॉर दॅट वी हॅव just checked the first value of the frame and compared it with the divisor. Okay, and if they are same, then the answer is 0, otherwise answer is 1. So this logic is for the XOR operation. Okay, and also we have decided the quotient as well as the remainder. Quotient, how we have decided here? So n of I, that is frame of I, frame ची value जर 1 असेल, then my quotient is also 1, otherwise quotient is 0. And automatically we'll get the value of the remainder as in f of array f. So in that we'll get a value of the remainder. Okay, so and remaining thing is only we have displayed the values, nothing else. So is there any doubt? Any doubt? Yes, any doubt? काय डाउट आहे का? समजलाय प्रोग्राम? Have you understood the program? Yes or no? Or should I repeat once again? Yes, tell me. Have you understood this program? Any doubt? Yes, Sneha Muskar, Gadge, Pratik. हाँ. Yes or no?
सगळा नाही समजला मॅम, पण समजला जस्ट
किती समजला आणि काय नाही समजलं?
70% समजला.
70 समजला, 30 नाही समजलं. ठीक आहे.
हा, प्रॅक्टिसने समजून जाईल.
लॉजिक तरी कळालं काय केलंय ते. बाकी काय
हो
लूप्स
मॅम.
किंवा व्हेरिएबल्स हे तुम्ही ज्यावेळेस प्रोग्राम ऍक्च्युअली एक्झिक्यूट कराल किंवा करून बघाल त्यावेळेस तुमच्या लक्षात येईल की का घेतलेलं आहे आणि कसं घेतलेलं आहे ते. ठीक आहे, लॉजिक तरी समजून घ्या आता सगळेजण. हा, बाकीच्यांना काही डाऊट आहे, समजले नाही समजले, रिपीट करायचंय, टेल मी.
रिपीट करा मॅम.
Okay. Any other? Okay, I'll repeat once again. I hope everyone will see this program at least, and afterwards you just try it. Okay. So what we are going to do here in CRC is that first CRC in CRC what basic things we need from the user is frame and the divisor. Okay, so for the frame also we need what should be the length of the frame and what should be the length of the divisor. So accordingly we have taken the input from the user. Okay, so first enter the length of the frame that we have stored in n1, then frame I have get entered in and it is stored in n. Okay, similarly I have taken the length of the divisor from the user in d1 and accordingly, the divisor is get entered and it is getting stored in div. Up to this, it is very simple. फक्त बेसिक काय घेतलं आपण युजर कडून फ्रेमची लेंथ फ्रेम, डिवायझरची लेंथ आणि डिवायझर. त्याच्यानंतर नेक्स्ट पार्ट व्हॉट वी डू इन CRC इज दॅट वी नीड टू ऍड झिरोज. ठीक आहे, सो झिरो शुड बी द लेंथ -1. डिवायझरची जेवढी लेंथ असेल त्याच्या -1 झिरोज आपण ऍड करतो. 5 असेल 4, 3 असेल 2, लाईकवाईज. And it should get added at the end of the frame. For that, I have taken one for loop which will start from end of the frame, which is nothing but this n1, and which will go up to the length -1. ठीक आहे, म्हणजे काय मला झिरोज ऍड करून पाहिजे आहेत. What I have written in for loop, n of I is equals to 0. ओके, सो दिस झिरो कुठून ऍड झाले पाहिजेत? n1 पासून. n1 काय माझी लेंथ आहे आणि कुठपर्यंत ऍड झाले पाहिजेत तर d1 -1. d1 काय माझी लेंथ ऑफ द डिवायझर. ओके, अकॉर्डिंगली नंबर ऑफ zeros get added. Now we are having the frame, we are having the divisor, we are having the number of zeros get added. Up to this, basic things are all over. Only thing, one thing remaining is that we need to perform the XOR operation and we need to check the answer. एवढंच करायचं. What is the XOR operation? If the same values are there, then answer is 0, else answer is 1. Simple thing I have kept in this if loop. If n of temp is equals to divj, is these two values are same. What is there in divj? What we have stored in div is your divisor. Okay, and n of temp, n मध्ये काय आहे तुमची फ्रेम आहे. जर दोन्ही व्हॅल्यू सेम असतील तर माझा आन्सर काय आहे तर n of temp is equals to 0. ओके, अँड एफ ऑफ जे काय तर रिमाइंडर आहे CRC. हा जर तुम्हाला इथं नको असेल तर फॉर लूपच्या बाहेर पण तुम्ही लिहू शकता, फक्त एंडचं CRC मिळेल त्यासाठी. बट आय हॅव जस्ट ऍडेड टू चेक इच अँड एव्हरी स्टेप. सिम्पल. सो आफ्टर एव्हरी ऑपरेशन विल गेट अ रिमाइंडर ओव्हर हिअर. ठीक आहे, सो इफ द सेम व्हॅल्यूज आर देअर, आन्सर इज 0. अदरवाइज आन्सर इज व्हॉट 1. And this will execute up to the whole for loop. But again also we have to decide the quotient. ठीक आहे, क्वोशंट कसा डिसाइड करतो आपण? फ्रेम मध्ये जर व्हॅल्यू 1 असेल तर माझा क्वोशंट काय असतो? क्वोशंट म्हणजे भागतो कशाने आपण? 1 न भागतो. 0 असेल तर 0 न भागतो. सिमिलरली इट हॅज बीन चेक्ड ओव्हर हिअर. इफ n of I is equals to 1, म्हणजे जर व्हॅल्यू 1 असेल तर क्वोशंट काय असेल? Q of I is equals to 1, else quotient is 0. ठीक है, so this is only thing, and after this only we have just shown all the values. Quotient काय आणि रिमाइंडर काय. Okay, it is simple. What I suggest you that you just first take this program. I'll forward this in group. So you first take this program, do it, and then think what is the function of which variable. प्रत्येक व्हेरिएबल काय करतोय हे तुम्हाला तिथं कळून जाईल. फक्त आता लॉजिक लक्षात घ्या. हाऊ टू टेक द एक्सॉर ऑपरेशन, हाऊ टू टेक how to check the quotient, how to check the reminder. So all that things you just take in mind for now. Still anybody is having doubt, you can ask. Is it clear or any doubt is there? No doubt ना? समजलाय प्रोग्राम? Okay, fine. So let's go to the next part. Okay. Okay, so CRC is over. After that, Hamming code is there. So Hamming code program is also there, but it is too huge program and I don't know how to explain it over here. So I'm finding some easy way to define this Hamming code program. So till now we'll stop on CRC program only. Hamming code I will tell you in afterwards. Next lecture I hope I'll tell you. Okay, so Hamming code, I hope everyone is remembering what is the purpose of the Hamming code, why it is used, and how to calculate the parity, how to calculate all this, error detect कशी करायची, correct कशी करायची. आठवते सगळ्यांना? Yes, Hamming code is what? It is error detection and correction code, correct? What is mean by the parity, how it is calculated? आठवते? Yes or no? आठवते. Okay. If there is no answer, then I'll consider it at yes, it is okay. Okay, so we'll go for the next part over here. Okay, so this is the, yes, I'm again asking you whether you understood the Hamming code or should I repeat? Hmm. Is it okay? आठवते? Okay, I'll show you the PDF of this Hamming code. From that, I hope you will understood. What is this Hamming code? आठवते का काय? कशासाठी होतं? हॅमिंग डिस्टन्स म्हणजे काय? कोडवर्ड्स काय असतात? आठवते? Okay, Hamming code is used for error detection and correction. What is Hamming distance? Hamming distance काय असतो? Suppose we are having these two code words and after performing the XOR operation, we'll get this answer. And according to the number of ones, we'll decide this distance. So number of ones are 2. It means that Hamming distance is 2. And code word is what? Whatever data or the frames are given that are considered as a code word in the Hamming code. ठीक आहे? So this is Hamming code and parity bits म्हणजे काय असतात? These are some extra check bits which are added in Hamming code to check the error. Error check करायसाठी parity bits add केलेले असतात. ठीक आहे? Where to add these parity bits? So for that we need to understand the structure of the Hamming code. ठीक आहे? So structure is what? So the power of 2 are always marked as a parity bit and other are the data bits. Okay, so power of 2 चे ज्या positions असतील, so all that are the parity bits and remaining all will be the data bits and accordingly we will form the Hamming code structure. Okay, so this is the Hamming code. After getting the Hamming code, we need to check how to define or how to define the error in the Hamming code. Okay, so parity calculation also we have seen how to calculate the parity. So suppose this is the overall structure of the Hamming code. So to calculate the parity bit P1, what we are what values we are considering. So check one skip one, check one skip one, likewise one P1 means one check करायचा skip करायचा. Suppose P2 असेल तर check 2 skip 2, check 2 skip 2, likewise. So to calculate the P1, what values we are considering? P1, D3, D5, D7. To calculate P2, what we are going to consider? P2, D3. Then uh, P4 and D5 will be skipped, and D6 and D7. Likewise, we can calculate the parity bit. And while calculating this parity bit, even parity is checked. Means number of ones should be get at the end of, and it should be get as a even values. ज्या नंबर ऑफ वन्स आहे ते काय असले पाहिजेत? इवन करायचे. सो वी आर चेकिंग द पॅरिटी बिट्स फॉर अ even parity, not for the odd parity. So every time make the parity as a even parity and you will get the values of the parity bit. Okay, so for that we have seen this example. So I'll tell you only how to, after calculating all the parity bit and the Hamming code, how to detect the error. Okay, so again, for detection of the error, we need to consider the parities. If it is odd, means if the number of ones are getting as a odd, then the value of that parity bit is 1, otherwise 0. And once we get the values of all parities, we can calculate the error. Okay, means we can calculate at which position the error is coming. How to calculate? So just calculate the, okay, so just how to calculate this error? So 2 raised to 1, 2 raised to 2, 2 raised to 4. So accordingly we'll get a value of error, and this value is nothing but the position where your error is occurring. Okay, so after getting this value, we have to just invert it. Invert means if 1 is there, make it as a 0. If 0 is there, make it as a 1. So this is all about the Hamming code. Many times we have seen this. So quickly we'll go to the next part. Okay, Hamming code is over. Then next is the elementary data link layer protocols. Okay, so this is important. Please pay attention. Elementary data link layer protocols means this data link layer protocol is having some, or it is getting divided according to the uses of these protocols. Means if the channel is noiseless, then such these protocols are used. If channel is noisy, then these protocols are used. Okay, so simplex, then stop and wait with ARQ, go back in ARQ, and selective repeat. So 5 protocols we have to see. So simplex protocol is just it just takes the packets and forwards it. Okay, so as the packet come to the protocol, it just forwards it to the receiver. But in reality, actually this is not a significant, or it is not a feasible protocol, because the size is also matter. Because according to the simplex protocol, every, I mean, sender can send any number of packets or any number of data, and it is not feasible. So that's why it is also called as a utopian simplex protocol. And this question is asked for the MCQ also. Please remember this. Okay, then next we have seen stop and wait protocol. Okay, stop and wait protocol. So according to the name, how it works, it just send the data. It waits for an acknowledgement from the sender, from the receiver, and once a sender get an acknowledgement from the receiver, then only it sends the next data. Okay, so this is the stop and wait protocol. It is very simple protocol for understanding and use, but it has having some problems, and these are the three problems. Maybe possible data get lost in between. So in that case, receiver will not able to set any acknowledgement, and both will wait for a longer time, sender as well as the receiver. Also, it may possible that data will reach properly. A receiver will send the acknowledgement, but acknowledgement will get lost. In that case, sender will wait for infinite amount of a time. And also, acknowledgement or data may reach, but it can reach after a long time. This after a delay. So these are some of the problems related with the stop and wait protocol. And to overcome these problems, the next protocol comes, which is nothing but the ARQ, automatic repeat request. Means instead of waiting for any of this acknowledgement from the receiver, what it will do, it will set some time, and after that time automatically the request will be resent, or the data will be resent. So that is the general idea. So timeout, if suppose data get lost after waiting for an some amount of time for acknowledgement, sender will again send the data, resend the data. So that is the solution. Similar thing is applied for the acknowledgement also. If acknowledgement is not reaching after some amount of the time, it will again resend the data. Okay. And delayed acknowledgement, so delayed acknowledgement or delayed data, it can be resolved by using sequence number. So already I have told many number of times the role of the sequence number. So in case of the data communication or the computer network, sequence numbers are added, or some specific numbers are added to every frame to recognize the sequence of a frame. Means which frame is there, which is reaching after which frame. So to analyze the proper sequence of all frames, some number specifications are given to every frame, and accordingly the sequence is decided. Okay. Then this is what, again, the sliding window protocol. We are having one more experiment on sliding window protocol also. So you can think on chapter number 3 we are having the three experiments. Okay, CRC, Hamming code, and the sliding window protocol. Okay, so sliding window protocol, in this how it works. Yeah, can anybody tell how sliding window protocol works? हा, कोण सांगू शकते का कसं करतात स्लाइडिंग विंडो प्रोटोकॉल वर्क कसा होतो? No, ठीक है. So I'll tell you how this sliding window protocol is actually working. So sliding window protocol is this is the method. Means actually whatever protocol we have seen, stop and wait with ARQ. So what is the case there? So everything is related with a single frame only. But in case of the sliding window protocol, multiple frames can be sent. Okay, or we are dealing with the multiple frames. Okay, how this is working? So this is the diagram, see here. So we are having the window size. Window is what? It is an imaginary part. Okay, so whatever size of the window is given, that much frames are sent at a single time, and for that window size is given. Okay, and suppose these are the frames 0 to 10, या सगळ्या frames आहेत, and window size is what? 4. So for a single iteration, total 4 frames will be sent instead of 1. So 0, 1, 2, 3. So that much frames will be sent instead of waiting for an reply, or instead of waiting for an acknowledgement. Acknowledgement येऊ अगर ना येऊ पहिल्या फ्रेमची, जर विंडोची साईज 4 आहे तर 4 फ्रेम सेंड झाल्याच पाहिजे. सो दॅट इज द वर्किंग प्रिन्सिपल. ओके, सो हाऊ दीज आर सेंड? सो यू कॅन सी 0, then next is 1, then 2 and 3. So total 4 frames are being sent. So you can observe here no acknowledgement for any of this is sent over here. Neither 0, neither 1, neither 2. कशाचीच acknowledgement अजून मिळालेली नाही. ठीक आहे. After that, next is what? Now all frames are reached over here. Maybe in between it may possible that the acknowledgement of 0th frame will get started. So you can see here. आता हे सगळ्या फ्रेम्स पोहोचतायत पण त्याच्यामध्ये 0 ची acknowledgement आलेली आहे. So what it will do? It will just change the position of this window. Okay, or in book what is given is that window is getting shrinked means what? हे काय करते तर स्वतःचं पोझिशन चेंज करतं. हाऊ इट इज गेटिंग चेंज? सो acknowledgement of 0 is reached over sender. So now the work of 0 is over, so it will move forward and it will take 4 into the consideration next window. So you can see here because size of the window is 4. 0 चं काम संपलेलं आहे. 0 सेंड केला, रिसीव्ह झाल्याची acknowledgement पण आली. मग 0 पशीच न थांबता विंडो काय होते पुढे सरकते आणि नेक्स्ट जो डेटा असेल तो त्याच्यामध्ये सेंड केला जातो. सो 4 विल बी सेंड. Similarly, if one's acknowledgement is sent, again it will move forward for the next frame. Okay, see here. So once acknowledgement आले, so 5 will be in a sliding window. So same procedure is applied for all the frames. Okay, so this is nothing but the sliding window protocol. It is very easy. Just what is there? बेसिक प्रिन्सिपल काय आहे की जेवढे विंडोची साईज असेल तेवढ्या नंबर ऑफ फ्रेम्स सेंड होतील आणि ज्या फ्रेम्स सेंड झालेल्या आहेत त्याच्या कुठल्याही acknowledgement साठी वेट न करता नेक्स्ट फ्रेम ऍड होत जाते. दॅट इज सिम्पल. ओके, सो दिस इज द sliding window protocol. Same for the sliding window protocol, it is divided into these two parts or these two protocols. Okay, go back N ARQ and selective repeat ARQ. Go back N. N is nothing but what is this N? It is number. Okay, so I'll show you quickly how this is work. Go back N. So go back N. In that same example we have taken. For example, same suppose 0 to 10 frames are there. Okay, 0 is sent, then 1, then 2, 3, 4, 2, 3. Okay, so after 0 acknowledgement, the next frame is getting added and 4 is sent, 1 is sent. Now go back and कधी वर्क होतो? सपोज acknowledgement of the next frame is getting lost. ठीक आहे, आता हे काय झाले 2 चे acknowledgement in between lost झालेले. तर in that case what it does? Okay, so in that case what it does, this window instead of moving forward it will go back to the original position. Okay, means acknowledgement ज्याची लॉस झालेले तिथपर्यंत ती विंडो परत येते and after that it will send all remaining frames. See here, so 6 पासून कुठे आली 5 ला आली, 5 पासून 4 ला, 4 नंतर 3 and नंतर 2. So it goes back to the original or for the acknowledgement जी lost झालेले त्या acknowledgement मध्ये ती येऊन थांबते. Then after that it sends all the remaining frames. So it will send again 2, 3, 4 and 5, all these 4 frames. So you can see in diagram 2, 3, 4 and 5. Though they are already sent. हे बाकीचे सगळ्या सेंड झालेले आहेत ऑलरेडी 3, 4, 5. Still though फ्रेम नंबर 2 ची acknowledgement रिसीव्ह झाली नाही किंवा इन बिटवीन लॉस झाली त्यासाठी पुन्हा सेंड झालं. Okay, so this is the go back N protocol. And similarly selective repeat. What is the difference in these two go back n and selective repeat is that in selective repeat it only selects the frame which acknowledgement is lost. आता दोनची acknowledgement lost झालेली आहे frame number 2 ची. So only frame number 2 will be sent instead of all these frames. Okay, so that is the only difference between the go back n and the selective repeat. So same example I have shown over here. Yeah, so you see here, you can see here the acknowledgement of 2 is lost. So remaining acknowledgement are reaching. So instead of forwarding all this frame again, what it will do, it will resend only frame number 2. ठीक है, so this is the go back n protocol. So here chapter number 3 is over. Any doubt? Okay, so I hope everyone has understood the seriousness of chapter number 3 because lots of part is there in chapter number 3. So most of the syllabus, I think I can say that it is covered in chapter number 3. Your first section is depend on chapter number 3. If you are very clear with the chapter number 3, then you can easily pass in your exam. Easily. Okay. So 2 times we have repeated this chapter. Okay, today was the second time we have taken this revision of all the points. Okay, so I hope there is no doubt. सगळ्यांना सगळं समजले. I think so. Okay, so wait for a minute. Yeah, by the time I need to show you one example. By the time, if anybody is having any doubt, you can ask me. Yes, any doubt, काही doubt असेल तर विचारा. Any doubt? No doubt. Right. Okay. So there are some questions which are asked in GATE examination that I need to show. I want to show you related with this chapter. So I just show you this thing in. Hmm. Okay, screen display. Yeah, screen is visible. Yes, ma'am. Okay. So some questions are there on stop and wait protocol as well as on the go back n protocol. So I'll show you some examples of this which are asked in GATE examination. So stop and wait protocol just now we have seen. Yeah. So before going to this GATE exam, this is called as a timing diagram for stop and wait protocol. Okay. Timing diagram is what will be the total time by considering all these transactions related with the frame. Means फ्रेम सेंड होत्या acknowledgement साठी वेट करणार आहे लॉस झालेला आहे सो ऑल दिस थिंग हे सगळं कन्सिडर करून एक फ्रेम रिसिव्हरला किती वेळात पोहोचेल that is shown over here. This is the timing diagram. Okay, now we'll see how to calculate this total time. It is given over here. So total time for one frame to reach to the destination and acknowledgement to the sender is calculated by using, it is equals to total time of data plus total time of acknowledgement and remaining time. Now what is this remaining time? You can see here. Okay, so total time of data means हे जे जाणार आहे तो प्लस टोटल टाइप ऑफ एक्नॉलेजमेंट, हा एक्नॉलेजमेंटचा जो टाइम असेल तो, आणि बाकीचा टाइम. आता बाकीचा टाइम काय असणार आहे तर सम प्रोसेसिंग साठी किंवा वेटिंग साठी some time is required, but initially it is considered as a zero, means it is negligible. खूप थोड्या वेळसाठी वेट करत असतो आपण, जरी डायग्रामॅटिकली दाखवतोय की लाईक दिस, हा वेळ एवढा वेळ वेट करणार आहे पुन्हा, बट दिस टाइम इज व्हेरी निग्लिजिबल बिकॉज यू कॅन रिकॉग्नाइज. आपण एखादा मेसेज सेंड केला तर विदिन अ मायक्रो सेकंड दॅट मेसेज इज रिचिंग टू द एंड पार्टी. Okay, so whatever waiting time is there, so that is negligible. So always it is considered as a zero. If it is given in question itself, then only we need to consider, otherwise no. Okay, so this is zero. So transmission time of data, transmission time of acknowledgement, then processing time is zero plus propagation time. You can see here TP. Okay, so TP is what propagation time. What is this TP? So you can see here, it is shown over here diagram मध्ये दाखवलेलं आहे. TP म्हणजे काय असतं तर पहिली फ्रेम सेंडर पर्यंत रीच होईपर्यंत पण काहीतरी टाइम लागणार आहे. ठीक आहे, सो दॅट इज कन्सिडर्ड ऍज अ प्रोपगेशन टाइम ऑफ सेंडर, ऍज वेल ऍज एक्नॉलेजमेंट पण सेंड होते. एक्नॉलेजमेंट रिसिव्ह सेंडर पर्यंत यायला पण काहीतरी टाइम लागेल, सो दॅट इज द प्रोपगेशन टाइम ऑफ द रिसिव्हर. ओके, सो how to calculate total time? Transmission time of data plus propagation time of data plus processing time, it is zero, plus transmission time of acknowledgement plus propagation time of the acknowledgement. So if you solve this formula, we'll get a formula as a transmission time of data plus 2 into TP plus transmission time of acknowledgement. So this is total time how we can calculate for only one frame. According to this total time, we need to calculate efficiency of the frame. Okay, efficiency of the frame is calculated as useful time divided by total cycle time. Useful time means एक्झॅक्टली किती वेळ घेतला त्या फ्रेम डिवायडेड बाय हा सगळा जो लागणार आहे तुम्हाला टाइम तो. ठीक आहे, सो इट इज कॅल्क्युलेटेड टीटी डिवायडेड बाय transmission time plus 2 into TP. Okay, so after solving this, we'll get this formula 1 upon 1 plus 2 TP by TQ. And according to the efficiency, throughput is also calculated. Throughput means what is the means minimum time किंवा हे सगळं consider करून exactly what time your frame is reached. So that is nothing but the throughput, which is calculated n into b. N means efficiency. Okay, now we'll see one simple example for this. जास्त काही कन्फ्यूज होऊ नका. इट इज नॉट आस्क्ड इन युअर एक्झाम. इट इज द गेट क्वेश्चन. इट इज डिफिकल्ट, I can understand, but just you need to understood the seriousness of chapter number 3. That's why I have taken over here. Okay, now this is the simple example on the stop and wait protocol, which is asked in 2017 gate question. ओके, सो जस्ट रीड अँड सी. फक्त बघा, जास्त काही डोकं तुम्ही ह्याच्यात, नंतर मी तुम्हाला पीपीटी प्रोव्हाइड करेल, त्यावेळेस तुम्ही प्रॅक्टिस करू शकता. Okay, so what is given here? The values of the parameters and for stop and wait with ARQ protocols are given over here. Okay, bit rate for the transmission channel is 1 Mbps. Then propagation delay from sender to receiver is 75 millisecond. Then time to process a frame is 25. Then number of bytes in frame are 1980. Then acknowledgement is 20, and overhead bytes in the information frame is 20. So this is all given over here. And from this we have to calculate. Assume that there are no transmission errors, means frame गेलेले आणि acknowledgement पण आलेले, in between no loss is there, that is given. Then transmission efficiency of stop and wait ARQ protocol for the above parameter is what? So what we have to calculate? We have to calculate the efficiency of this protocol, means how efficiently stop and wait protocol is sending the frame, that we have to calculate. Okay, so in gate question paper, some questions are MCQ based, some questions are we need to specify the answer. So here we have to calculate and specify, and your answer should be correct. Okay, then only you will get the marks. So this is given, number of bytes हे सगळं दिलेलं आहे. Now from this we can calculate the transmission time. So what is the formula for the transmission time? It is given. Okay, so transmission time is calculated as L upon B. Okay, L upon B. L is nothing but how many bytes it is sending. So it is converted first into the bits, because as 1980 it is given into 8 divided by 10 raised to 6. It is given in question only. Okay, accordingly we'll get a transmission time is equals to 15.84. After solving this, then similarly acknowledgement is also given 20. Okay, so they have given the acknowledgement, so we can calculate the transmission time for the acknowledgement also. So same formula we can use, 20 into 8 divided by 10 raised to 6. So we'll get 0.16 millisecond answer. So this transmission time is for data, and this transmission time is for the acknowledgement. Okay, from these two, now what is the, now the propagation delay from sender to receiver is given in question itself. It is given as 0.75. So round RTT means what? Round trip propagation or the transmission. It is calculated as 2 into TP. So we'll get 1.5 millisecond. After this, we need to calculate the efficiency only. Okay, so efficiency is what? Already we have seen the formula. Efficiency is what? Useful time upon the total time. Useful time is what? Transmission time of this one, transmission time 15.84 and 0.16. So this is the useful time and divided by the total time. Total time मध्ये काय येणार? हे राहिलेले सगळे जे टाइम आहे ते त्याच्यामध्ये टाकून द्यायचे. Okay, so when we put all these values, we'll get this answer. 0.88 is the correct answer. I know nothing will be understood. काही समजलेलं नसणार आहे. Still see the example. I'll forward this PPT. हे सगळे formulas आहेत. These all are depend upon whatever we have seen. जे आपण बघितलेले आहेत concepts, depending upon that these formulas are calculated, and this is the timing diagram. It is not given in any book, nowhere. Whatever we have seen, we have studied, accordingly this timing diagram is designed. Okay, and from that we can solve this example. So this is the whole example, and the correct answer is 0.88. This is how the questions are asked in the GATE question paper also. Okay. There are many questions on this chapter itself, so I'll just show you. See, you can see here. This is also related with the stop and wait protocol only. Okay, here also we have to calculate the efficiency. Okay, how to calculate the efficiency, that is given. This is also a simple example. A channel has a bit rate of 4 kbps and propagation delay of 20 milliseconds. For what range of the frame sizes does stop and wait protocol gives an efficiency of 50%? So what we have to calculate, efficiency 50% असेल तर फ्रेमची साईज मॅक्सिमम किती असणार आहे? So that we have to calculate, means length we have to calculate. So if we use this formula, then we'll get this answer. Okay, this formula already I have defined in first timing diagram मध्ये हा दिलेला formula. Okay, so length will be 160 bits. Again in 2005, so they have asked the question. Then this also is the gate question, that efficiency we have to calculate. Also questions are there on the sliding window protocol also. Okay, so whatever concept we have seen, so see here this diagram I have shown. So similarly, for the sliding window protocol also the questions are the in gate question paper. Okay, selective repeat is also there. Also on the go back n protocol is also asked, like this go back n protocol. The questions are there on go back n also. These are simple questions. So go back n as compared to the stop and wait and selective repeat, go back n is very simple. Means without any formula we can calculate the answer. You can see. I'll show you one example. In go back 3, 3 is what? Number, means n ची value काय आली? 3 आली. Flow control protocol, every sixth packet is lost. So what they have given, every sixth packet is lost. If we have to send total 11 packets, means size किती आहे? Total 11 packets send करायचे. How many transitions will be needed? टोटल 11 पॅकेट सेंड करायचे अँड त्या 11 मधले प्रत्येक 6वं पॅकेट लॉस्ट होते. सो वी नो हाऊ गो बॅक एन प्रोटोकॉल वर्क्स. हाऊ इट वर्क्स? सो जिथे लॉस झालं तिथून पुढचे सगळे पुन्हा रिसेंट होणार आहेत. ठीक आहे. सो अकॉर्डिंगली हाऊ मेनी ट्रान्झिशन्स आर रिक्वायर्ड. So you can see this diagram. So sender and receiver is there. ठीक है. So first frame sends second, third, fourth, fifth, sixth. Now what they have given? What they have given? 6 packet is lost every time. प्रत्येक वेळेस काय होतं? 6वं packet lost होणार आहे. So 6 packet is getting lost. Now 6 packet is lost. It means that total 11 packet send करायचे. Means याची acknowledgement आली. So next packet जाईल. Okay. So similarly for next all packets 6, 7 and 8 again retransmission will appear. 6, 7 and 8. ठीक आहे. सो दिस विल गेट रिट्रान्समिशन. सो रिट्रान्समिशन नंतर जिथून रिट्रान्समिट झालेले आहेत तिथून पुन्हा काउंट करायला सुरुवात करायचं. 1, 2, 3, 4 लाईक वाईज. अँड अगेन ऍट द एंड वी विल गेट दिस. Okay, so how many transitions are required? So total 17 transitions are required to send 11 packets if every 6th packet will be lost. So that is the thing. Only diagrammatically go back n मध्ये कोणताही फॉर्म्युला लागत नाही. Okay, so same questions are asked many times for the go back n. Also they have given the window size here 3. Okay. Okay, so this is what about the go back n and the sliding window protocol. So third chapter is over from my side. There is one quiz. I'll update it today itself. So from tomorrow's lecture, I'm going to start the next chapter, chapter number 4. So first section is over. Total 3 chapters are there. So first section is over. Okay, so we'll stop over here for today. Tomorrow I'm going to start the next chapter. I'll share you one link today. On that there will be a test. You just solve it and submit it. You can solve it anytime, today or tomorrow you can solve it, no doubt. So you just solve it. MCQ test is there on three chapters. Okay, so we'll stop over here.